Algebra 2, lesson 8.3. What we see here is a formula for compound interest. If you have a bank account, a savings account at a bank, and you're receiving interest, it's like a gift from the bank to you for being their customer, you might get interest multiple times a year. And when that happens, you can earn interest on your interest. Hence, the compound. So P is what we're going to have for a starting value. It's known as our principal. R is your annual interest rate. It's your annual interest rate that's in a year, but you need to have this as a decimal. We're always going to divide our percent by 100 to get that. N is the number of times you get interest. And then finally, T is, we're looking at this formula right here. T is the number of years. So the thing is, your N could occur just once. Annual means yearly, and that means you would receive interest one time. Semi-annually means that you'd receive interest twice. Very commonly, you might receive quarterly. There are 4 quarters in a dollar, 4 quarters in a football game, in a basketball game. So that would be receiving interest 4 times. Monthly means that every month you receive some interest. There are 12 months in a year. So let's go ahead and see what would happen. And this can also be not just interest that would be accumulated for you, but it could also be interest that you are collectively being charged if you are in a loan. So example 1 is such a case. This is not receiving interest from the bank as a gift. He's borrowing $8,000. So P is what he is starting with. As you look at 7.5, as we read this rate of 7.5, we can see that we can take 7.5 divided by 100. And I strongly advise that whatever percent you have, you take care of that. You don't want this to be the reason why you get the problem wrong. If he were not to make payments, how would this accumulate? This is how people can really get into debt. This is semi-annually, by the way. It's compounded semi-annually, so N is going to be 2, and T is going to be 9. So we've got this formula up at the top. A is equal to P, 1 plus R over N raised up to the T. You can see it's $8,000. 1 plus 0.075, divide that by, and by the way, it's NT, pardon me. Up here, 0.075 divided by 2. Your N right up here is a 2 times 9. And this is where we just let the calculator punch this out for us. So we'll get 8,000. And we'll say 1 plus, then we'll say alpha y equals, we'll say 0.075 all over a 2. Bump that up here to N times T, that's 2 times 9. And they want us to go to the nearest cent. That's the nearest penny, $15,519. And 43 cents. So if you're not making any payments, that's the interest that's going to accumulate. You can see that you've almost doubled the amount that you owe. Let's take a look at, very quickly, how we can go ahead and just deal with the exponential growth model. Y equals A times 1 plus R up to the T. Decay, we've already seen that in a previous lesson. Y is equal to A times 1 minus R to the T. And let's take a look here. It says a principal, that's your A, that's what you're starting with. Was invested at 5.25% interest. So Once again, let's just go 5.25, divide that by 100. So our R is 0.0525. It's compounded annually. We're going to really just deal in this situation with one of these two boxes up here. Let T be the number of years. We honestly don't know how many years we have total. We're just going to write an exponential function showing the relationship between y and t. So its growth, we're going to use this top box up here. Y is equal to 4,900. Then we'll have 1 plus 0.0525 raised up to the t power. Now, if you wanted to, you could even add these two together. 1.0525 raised up to the t. That's all they're asking you to do. They're not asking you to work anything out in particular. Let's take a look at something where you could see depreciation. You could see decay, and that's going to be this other formula right here, where the value of some item, whether it's with technology or in this case a car, it's going down. So a car is bought a starting value of $19,500. Your interest rate here, your R, well, your rate, it's really not for interest though. You know, the rate of growth or decay is 22%. This is a decrease of 22%. You can see that's 0.22. We don't know the number of years exactly that we're dealing with. Just go ahead and plug that in. We'd have y is equal to 19,500. Then we'll have 1 minus 0.22. Now, of course, if we were to work this out, 1 minus 0.22, you could see is 0.78. So we get y is equal to 19,500, 0.78 to the t. And that would be your decay function. It's the exponential function showing the relationship between y and t. Guys, we have one last problem here, and we're trying to solve for x. What you want to do is get the same base. You want to have the same base. So what we're going to see is simply this. This 25 is really 5 to a power. 25 is really 5 to the second. So I'm going to write 25 as 5 to the second and then put a negative x minus 2 up here. 125 is actually 5 to a power also. It's really 5 to the third. So I'm going to write this as 5 to the third power. But you might remember the property of exponents. If you have x to the a raised to the b power, that's where we go powers to powers. And we're going to distribute, multiply that 2. 2 times negative x, you'll get a negative 2x. 2 times negative 2, you'd get a minus 4. As we're wrapping up, I hope you can see that the only way this statement could ever be true is if the powers are equal. Look, if I have 5 to a power is equal to 5 to a power, the only way that's true is if the powers are one and the same. So off to the side here, I'm going to say 3 must equal negative 2x minus 4. The exponents have to be the same. So first, get the same base. Make sure that you'll have the same base, and then set the powers equal. I'm going to add a 4. 3 plus 4 is 7. And then I'm going to divide by a negative 2. And 7 divided by negative 2 is negative 7 over 2. And that is our final answer.